Now we're going to use the Trivial Web Server program to investigate the return codes coming from children to their parents. Now, the only way a child can tell a parent that it had a good life or a not so good life is through this single integer value, the return code or the process exit status code. And the way it works is a parent forks a child and then waits for the child to die. When the child's died, the parent can then inspect the return code from the child and see whether the child had a good life, a 0 return code means a good life, or a not so good life, a non-zero return code. And the reason we use 0 for good is it's easy in a programming language to check for 0 or not 0 and then look at all the possible values of not 0. There's really only one good and many reasons things could be bad. So now we're going to run our Trivial Web Server again. And this time we're going to run it without the -s option so that it responds very quickly to requests. It tells us it's listening on 8080 and it has a process ID of 5104. Again, we're going to use wget to fetch a page, and we're asking for foo.html. Well, there it went all quickly, and the child worker process returned a status of 0. So our worker process told the parent everything went fine, nothing to worry about. But if we ask for the special page oops.html, the worker returns with a status of 1. The whole point of this exercise is to show you that from child back to parent, there's really only one value that gets passed back, and that's the status. And the child doesn't pass it back directly. The kernel maintains a process table for every process that's running, and that process table says what's the process ID, what's the parent process ID, and what's the return code. There's a spot in there for the return code. So when this process terminates, it can't be removed from the process table as long as the parent might ask about it. So if the parent's running and the child is terminated, the kernel has to keep this entry in the process table until the parent asks for it. Now, what happens if the parent doesn't ask for it? What happens if the parent creates a child process, forks a child process, the child process terminates, leaving a return code for the parent, and the parent never asks? Well, the kernel can't get rid of that process in the process table for fear the parent might ask for it later. So it has to keep an entry in the process table just in case the parent asks. Now this state is a little funny. The process is finished running, but the kernel's list of processes, the process table, still sees it as there. So it's dead, but it's not dead. Maybe we should call that a zombie. Let's run without the -z option, which means we're not going to clean up, and we're going to leave zombies. And when we get a page, good, bad, or indifferent, doesn't matter, you'll see that every time we get a page, I'm spawning a child, child completes, but the parent isn't checking the return code. So that when I check for my TWS processes, you'll now see that I have the original TWS process that's listening, but I've also got 2 defunct processes, which are also known as zombies. They're zombies because they're in the process table, but they finished running. Now, the kernel can't get rid of these until either TWS asks about their status or until TWS goes away. Because if TWS dies, the kernel knows for sure that it's never going to ask about the status. So you'll see that if I hit Control-C here and terminate TWS, the zombies go away. So if you've ever wondered how to kill a zombie, at least in Unix, if you kill his parent, the zombie will die.